So this is taking some, this is a short video on solving inequalities, both polynomial inequalities and rational inequalities. And this is really, we're just going to use some stuff we already know from the polynomial and the rational stuff we've done already. So in this case right here, where you're trying to solve this polynomial inequality, notice it's already in factored form, because that's what we would do. We've already talked about getting things into factored form. So once you get it in factored form, it's pretty easy to, as we've done before, sketch this. So we know that this is basically, if we were to think of this as just y equals for a moment, like y equals that, so forget about the inequality for a moment. If we were to just think of this as y equals x plus 2 times x minus 3 times x plus 5, then we could draw a quick sketch of it. So that would be, let's see, it crosses at -2, crosses at 3, and crosses at -5, right? And it's a third degree polynomial, so we know that it's positive leading coefficient, so we know it's going from low to high. In other words, in behavior is on the left is negative infinity, in behavior on the right is positive infinity, so we know it's doing something like this. Yeah? Okay, so now we're going to erase that and we're going to actually answer the question. The question was, when is this thing less than or equal to 0? Well, notice we've just drawn a picture of when it's less than or equal to 0, because what we're talking about here is the y values. So notice you can see right here that those y values are bigger than 0, and these y values are smaller than 0. So really, to answer this question, we just got to draw a quick sketch of it, and we would say, okay, the solution to this is from negative infinity to -5. And because this says it can be less than or equal to 0, we're going to put a square bracket there. And then from -5 to -2 doesn't work because that's above. And then we can pick up it again at -2. And again, we're going to put a square bracket because it can be equal to -2. And it's going to stay below the x-axis until we get to 3. So we put a 3 there, and we'll put a square bracket there. And then after 3, it goes back above, and it'll never come back again. So this would be the solution to that inequality. Okay? And we can do a similar thing with a rational inequality. So the first thing we do is factor it. So we go x minus 2, x plus 2 on top, and x plus 2, x plus 1, and we're wanting that to be greater than 0. So again, I'm going to think about, okay, this thing, because of my experience with rationals, I know the roots on top are 2 and -2. The roots on the bottom are -2 and -1. This is going to be a whole. And the 2 and the -1, or the 2 is going to be a x-intercept. The -1 is an asymptote. And so we know those are the only two places where you can cross from above to below. And so let's do a quick sketch here. We need to figure out where the -2 is. So remember, you cross this out and plug in -2. So that'd be -2 minus 2 over -2 plus 1. And that would be what? -4 over -1, which would be 4. So -2, 4. 1, 2, 3, 4 is a whole, right? So we know we're above the x-axis there, which means we're expecting something like that, right? Which means because there's only one factor of x plus 1, this asymptote comes from that factor. It means it has a multiplicity. This root has a multiplicity of 1. So that means I'm going to be below here. And we know we're just going to cross there and go up. So we know that we're above the x-axis here, below the x-axis there, and above it again over here. So if we want to go back to this question, it says, when is it greater than 0? That means above the x-axis. So that would be from negative infinity to -1, and then again from 2 to positive infinity. Notice in both cases I put a soft bracket or a rounded bracket because there's no equal sign here. So we want everything to be greater than 0, not greater than or equal to. So negative 1 would be a bracket because it's an asymptote. So even if I had equals there, I'd still have a soft bracket. But 2 would be a square bracket if I would have had an equal to there. But I don't. So that's why I put a soft bracket. Okay. So that's a quick lesson on solving inequalities, whether they're polynomials or rational.